Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. We've already learned the quotient identities, which are relationships that link sine, cosine, tangent, and cotangent together. Today, we'll unlock another set of powerful relationships, the Pythagorean identities. These come directly from the geometry of the unit circle and let us connect trig functions in even more ways. So let's take a look at what they are. So here, we have the three identities. The first one is cosine squared x plus sine squared x is equal to 1. And then we have two other ones. So you'll notice that I highlighted the first one in yellow and then the other two in pink. And the reason is because you only need to remember the very first one. The other two can be easily derived from the first one. So all three of them belong in this set called the Pythagorean identities. And as we do the proof for the first statement, you'll see why it's named that way. So a quick note on notation. When we say cosine squared of x, this is equal to cosine of x all squared. This is not equal to cosine of x squared. So now let's take a look at the proof for the first one. So what we're going to do is draw a right angle triangle. And we're going to call this angle here our angle x. So then we have our adjacent side, we'll call that A. Our opposite side, we'll call that B. And then our hypotenuse, which we will call C. So if we start with cos squared of x plus sine squared of x, this is going to be equal to, well, cosine of x is just adjacent over hypotenuse. So that is going to be A over C, and we're squaring that. And similarly, sine squared x is going to be equal to opposite over hypotenuse, and we're squaring that. So now if we square both of these fractions, we're going to get the first one is a squared over c squared, and then the second one is going to be b squared over c squared. And since they have a common denominator of c squared, we can go ahead and combine our fractions. So this ends up being a squared plus b squared over c squared. But wait a second, we're actually dealing with a right angle triangle here. And the Pythagorean theorem says that a squared plus b squared is equal to c squared. So therefore, our numerator, which is a squared plus b squared, can be replaced with c squared. So now we have c squared over c squared. And this is just equal to 1. And thus, we have shown the identity that cos squared x plus sine squared x is equal to 1. This is a particularly cool result because it's telling us that it doesn't matter what angle we choose to use. When we substitute the angle into x, it always works out to be equal to 1. Next, we're going to take a look at proving the other two identities. So we're going to start with our first identity now that we've proven it. So we have cos squared x plus sine squared x is equal to 1. Now we're going to divide both the left side and the right side by cos squared x. So we're going to get cos squared x over cos squared x plus sine squared x over cos squared x is equal to 1 over cos squared x. Now if we simplify this, we get this as 1 plus, and sine squared x divided by cos squared x is just tan squared x. We went over that in our quotient identity. And then 1 over cos squared x is just secant squared x. And now we have proven our second identity. The third identity is going to be very similar. So we start with our cos squared x plus sine squared x is equal to 1. But this time, we're going to divide both sides of this equation by sine squared x. So that means on the left side, we get cos squared x over sine squared x. So that is cotangent squared x. Plus, and then we're going to have sine squared x over sine squared x. So that'll be 1. And then the right-hand side is going to be 1 over sine squared x, and that is just cosecant squared x. And now we have proven all three identities. And like I mentioned earlier, the only one that you need to remember is the first one, because the other two can be easily derived. Next, we're going to take a look at how we can use these identities to make our lives easier. For our first example, we're given that sine of x is equal to 3 over 5, and x is in the first quadrant. We're asked to find cosine of x. So we've done questions like this before, where we would draw a right angle triangle and then use our quadrant knowledge to figure out what cos x is. But here we want to demonstrate the power of these identities to get to the same solution. So we're going to start with our identity, which is sine squared x plus cos squared x is equal to 1. So since we know that sine x is equal to 3 over 5, substituting the value in would give us 3 over 5 squared plus cos squared x is equal to 1. Now subtracting 3 over 5 squared from both sides will give us cos squared x is equal to 1 minus, and 3 over 5 squared is just 9 over 25. So therefore, cos squared x is equal to 16 over 25. And now we just need to square root both sides. So we end up with cos x is equal to positive or negative 4 over 5. However, because we are in quadrant 1, we know that cos x must be positive. So therefore, the solution is cos x is equal to positive 4 over 5. For our next example, we're asked to solve this equation here. So using our Pythagorean identity, we know that 1 plus tan squared x is equal to secant squared x. So let's go ahead and replace that. So we get secant squared x is equal to 3 times secant of x. Now moving all the terms to the left side is going to give us secant squared x minus 3 secant x is equal to 0. Now we're going to factor the left-hand side. So we can take out a secant x, and we're left with secant x minus 3. And that is equal to 0. So therefore, we have two equations to solve. The first one being secant x is equal to 0, or our second one being secant x minus 3 is equal to 0, which means secant x is equal to 3. But remember how secant x is just the reciprocal function of cosine. So if we rewrite this, we get 1 over cos x is equal to 0, or 1 over cos x is equal to 3. So looking at the first one, we have 1 divided by a number is equal to 0, and that's never going to happen. So which means here we have no solution. Now the second one, if we flip the fraction, we get cos x is equal to 1 over 3. And that one does have a solution because we know cosine of x oscillates between -1 and +1. But because this is not going to be a special angle, we're going to have to use our calculator. But here, I'm just going to leave everything in exact form. So if we were to use our calculator, we would say x is equal to, and remember we're always looking for the reference angle, so we're going to call this xr, is equal to arc cos, which is also cos inverse, of 1 over 3. And once we have our reference angle, we can use that to find our angles in standard position. So because our domain here is x between 0 and 2 pi, we know that using our ASTC rule tells us that we would have cosine being positive in quadrant 1 and quadrant 4. So if our reference angle is arc cos of 1 over 3, then that means our angle in standard position, we're going to have x is equal to arc cos of 1 over 3. So this would be the solution in quadrant 1. And then our other solution would be x is equal to 2 pi minus arc cos of 1 over 3. And this would be the solution that's in quadrant 4. And now let's do a quick recap of everything that we covered in this video. We learned that the Pythagorean identities come directly from ratios in the right angle triangle, and they link pairs of trig functions together. You can use these identities to find missing values, simplify, and solve trig equations, and we'll be using them to do proofs in the next video. And now it is your turn to give this a try. Can you find the solution to this problem on the screen here? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on trig identities in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.